Alrighty, so we're going to be looking at problem number 25, and this is going to be the figure that we're going to be referring to, so keep that in mind. I'll zoom in so you can see that real well. And so go back and read what all was given. But for part A, we were asked to find the direction of dB over dt. We know that it's going to be in the direction of negative z, because we know that it's going to be the decrease in current is going to be in the clockwise direction in coil 1, so it's going to decrease the magnetic flux, and it's going to change the magnetic flux, which is going to induce the EMF in the second coil, producing the current in coil 2 that's clockwise, and then so that's going to produce an induced magnetic field along negative z, so that it opposes the original flux. And I just kind of wrote that answer up here just so we don't forget that and can think about it as we go along. So for part B, we were asked what is the direction of the electric field inside the wire of the coil. And so we know that that's going to be a curly electric field, which as many people refer to it as the non-Coulomb electric field. So the direction of that depends on dB dt. And so as you know, use the right hand rule, thumb points in the direction of dB over dt, then use the fingers to curl in the direction of the electric field, which is going to show you that it's going to be down the positive x-axis, because it's going to be clockwise at the top of the coil. And so that is part B. At part C, I just kind of wrote all the givens right here, and kind of wrote what we're supposed to be looking for and what we're supposed to be doing. We were asked to find the flux, and so we know that first of all we need to find B1, and I did that here. Just kind of solved for that. It's 2 pi r1 squared, I sub naught z squared plus r squared raised to 3/2 times the number of turns in the wire. And so I did that, plugged all that in there, got my 8.23 times 10 to the negative third Tesla. So I did that there, and then I'm going to plug that into my formula for flux. And then we were given the area in the equation, which we know that the area is pi r squared. We were given the radius. And we know that for D, we were asked to, what is the magnetic field of the non-Coulomb electric field inside the wire at coil 2. And there's going to be a uniform flux over that coil. And we're going to just assume that. And that it's going to be uniform. And so that's going to be how you do part D. So for E, I always do this. I always write what's given there. So that when I'll go to work it out, it's all right there. It's all real handy. That's a good habit. And also the habit to draw images with everything. I drew mine on a separate piece of paper, which always works for me. So anyway, here we need to find B2 so we can find the flux of B2. So we did the same thing we did up here. We're just going to plug and chug, get that Tesla, and then plug that back in here because we were given that area. And then we have 4 more parts. So part F, we were asked to, what is the EMF in 1 turn? And so we know that D times the flux over dt is going to be equal to that EMF. So we're just going to plug that formula in right there, plug and chug, and do the same thing. We just got to make sure we have our formulas correct, make sure we change anything before we plug in numbers, because that's going to help make sure we get the answer correct. And in part G, we were supposed to figure out what's the reading on the voltmeter. So we know voltage is equal to number of terms, the flux, minus the flux 1 over dt. Same thing with that, just plugging and chugging, putting those numbers in there and getting that answer. And so for part H, we are asked to, what is the magnetic of the non-Coulomb electric field inside the wire of coil 2? So we know that E and C is equal to V over 2 pi R. Plug that in there, do the same thing, plug and chug. And I, it says at T is equal to 0.5 seconds, the current in the coil 1 becomes constant at 5. Which of the following statements are true? And so it gives us a few different options, but we know that it's only going to be options 1 and 4, because 2 isn't correct because there is going to be an electric field. 3 is incorrect because the voltmeter reads 0, and 4 is incorrect as well. And so we know that the coil is going to become constant at 0.5 seconds, so there's no change in flux.